Forget bricks and mortar. We're blasting off into the cutting-edge galaxy of construction technology. No laser is left unturned. No smart helmet is unexplored as we reveal the groundbreaking innovations that are redefining tomorrow's buildings. Prepare to be amazed, inspired, and perhaps a little intimidated by the future of construction. Are you ready? Let's dive in. In our contemporary era, lasers have transcended their traditional role as dazzling light displays and emerged as indispensable tools in various industries, with one of the most groundbreaking applications being light detection and ranging, LAR, technology. LAR represents a paradigm shift in the field of construction, where its capabilities extend far beyond the creation of visually appealing images. Instead, LAR is a revolutionary tool that harnesses laser technology to generate highly detailed 3D maps with unparalleled precision. This technological marvel has become a game changer by significantly enhancing worker safety in construction projects. LAR is good at mapping construction sites in a detailed way. It helps project managers and workers understand the area and possible dangers well before they start working. This helps prevent accidents and injuries and makes planning and carrying out construction projects better. LAR not only looks good, but also makes construction projects more efficient, safe, and successful in today's world. In the ever-evolving landscape of occupational safety, the quintessential hard hat has undergone a transformative upgrade, bringing it squarely into the 21st century. What was once a symbol of manual labor now embodies a fusion of cutting-edge technology and practical utility. These contemporary hard hats are not just pieces of personal protective equipment, they are smart, connected devices designed to revolutionize workplace safety. These smart helmets provide more than just head protection. They have special sensors and communication tools that allow them to function as real-time safety guards for workers in a variety of jobs. These helmets keep track of where workers are and how they move, making it easier to spot anything unusual or dangerous. This reduces the likelihood of accidents. It represents a significant departure from the traditional view of hard hats as passive safety equipment. Now, these high-tech helmets actively use data to improve workplace safety. Consider them virtual guardian angles, constantly keeping an eye out for those who wear them and making workplaces even safer. Buildings are transcending their traditional roles as inert structures in the changing landscape of architecture and construction, ushering in a new era of intelligence via smart infrastructure systems. These systems, which are outfitted with advanced sensors and predictive analytics, are transforming structures into sentient entities capable of detecting potential structural issues before they become visible. This paradigm shift in construction technology not only ensures occupant safety, but also increases the longevity and resilience of structures. These smart infrastructure systems constantly monitor various parameters, such as structural integrity, environmental conditions, and material wear using real-time data and machine learning algorithms. This proactive approach identifies potential structural weaknesses or vulnerabilities before they become visible problems. As a result, construction sites become inherently safer, and structural durability improves significantly. This not only reduces the risk of unforeseen structural failures, but also results in significant long-term cost savings. The incorporation of sentient features in buildings represents a revolutionary leap forward in the field of construction, ushering in an era where structures actively contribute to their preservation and the well-being of those who inhabit them. The integration of virtual reality, VR, in construction has ushered in a transformative era for novice workers seeking to hone their skills in a simulated environment. This groundbreaking technology offers a unique training platform that goes beyond traditional methods, providing an immersive and realistic experience for individuals entering the construction industry. Aspiring construction workers can now engage in lifelike scenarios through VR simulations, allowing them to practice various tasks and maneuvers that mirror on-site challenges. Using virtual reality, VR in construction training helps people learn new skills and makes safety better. When trainees experience a virtual construction site, they can learn about dangers and practice staying safe without real risks. This hands-on learning makes new workers feel more sure of themselves and lowers the chance of accidents on real construction sites. The construction industry is adopting VR to improve skills and make the workforce safer and more skilled as technology gets better. The axiom "time is money" holds particularly true in this industry, and AI emerges as a game changer by not only accelerating planning processes, but also infusing them with unprecedented intelligence. Project scheduling, resource allocation, and cost estimation, pivotal facets of construction management, are meticulously optimized through AI algorithms. This technological leap transcends the conventional boundaries of speed, ensuring that every decision made is not just quick, but also supremely informed and efficient. AI in construction planning doesn't just speed up tasks, it changes how decisions are made. Algorithms use big sets of data, learning from past projects and current factors to predict and suggest actions. This helps project managers and stakeholders foresee challenges, use resources smartly, and make cost estimates more precise. This leads to a big change in how construction projects are planned and done, with AI and human skills working together for a more flexible, responsive, and cost-efficient industry. As AI gets better, it could not only change project schedules, but also what we mean by efficient construction. In the not-too-distant future, the construction industry will undergo a revolutionary transformation as 3D printing technology becomes more widely adopted. Consider a world in which traditional construction timelines, which can last weeks, are compressed into a matter of days as 3D printers meticulously craft walls, ceilings, and floors with unprecedented precision. This technological advancement not only speeds up the construction process, but also causes a seismic shift in affordability, sustainability, and design flexibility in the housing sector. The advent of 3D printing in housing holds the promise of a more accessible and efficient approach to building homes. The reduction in labor costs is a game changer, as the intricate and time-consuming tasks involved in traditional construction are seamlessly automated. Additionally, the process significantly minimizes material wastage, contributing to a more environmentally sustainable construction methodology. The most exciting aspect, however, lies in the limitless design possibilities that 3D printing affords. Customization becomes the norm rather than the exception, allowing individuals to tailor their homes to their unique preferences and needs. This transformative technology emerges as a beacon of hope, particularly in regions grappling with housing shortages, offering a faster, more cost-effective, and environmentally conscious solution to address the global demand for affordable and sustainable housing. Exoskeletons have emerged as a groundbreaking reality in the ever-changing construction landscape rather than a science fiction fantasy. These wearable devices are transforming construction sites by enhancing human strength, increasing overall efficiency, and prioritizing worker safety. The use of exoskeleton technology enables construction workers to lift heavier loads with less physical strain, lowering the risk of musculoskeletal injuries. This technological advancement not only increases individual worker productivity, but also represents a significant step toward creating a safer and more sustainable construction environment. The arrival of humanoid robots, like the HRP-5P, is changing how we build things. These robots are super smart and can do tricky jobs in construction well. When we use them, projects get done faster, and there are fewer mistakes. These robots take care of the boring and tough jobs, so human workers can focus on the more interesting and creative stuff in construction. It's like teamwork between humans and robots to make construction smoother. A noteworthy transformation in the construction industry is the shift towards collaborative robot swarms. Unlike traditional notions of large, single-purpose machines dominating construction sites, these small robots work in perfect harmony, adapting to dynamic environments and collaborating seamlessly to achieve complex tasks. This paradigm shift not only enhances the speed and precision of construction projects, but also significantly reduces on-site accidents. The ability of robot swarms to work collectively, respond to changing conditions, and share information in real time represents a fundamental reimagining of how construction processes can be optimized. As the construction industry continues to embrace these advancements, the future holds a promise of safer, more efficient, and technologically driven construction sites. As we look toward the future, these technologies will redefine how structures are built, envisioned, and revolutionized. I'm eager to hear your thoughts and visions for the future in the comments below. Don't forget to like, share, and subscribe for more glimpses into the future. Until next time, keep building the future.